Hi, I'm Dale Miller, Vermont Senior Location Executive for GLOBALFOUNDRIES Fab 9. I would like to welcome you all to Essex Junction and Williston, Vermont location. In 2015, GLOBALFOUNDRIES took ownership of this campus, which has a rich history of over 60 years of innovation and technical leadership. Our 725-acre campus includes over 30 buildings with 3.5 million square feet of clean room, lab, and office space. Our innovative technologies are used in consumer products around the globe. We are a trusted source for the U.S. Department of Defense and the National Security Agency. Our campus includes a semiconductor fab, photomask manufacturing, technology development, a wafer probe and test facility, and advanced materials labs. We are the largest manufacturer in the state of Vermont, and we have won numerous national, regional, and state awards for environmental, safety, and energy management. We are very proud of our culture of giving back to the community, including many important local and regional causes. Today we will take you on a tour of Fab 9. Let's start with the facilities team.
Hi, my name is Dustin Newfer. Welcome to our Central Utility Plant Control Room. I'm a chemical engineer here at GLOBALFOUNDRIES. I began my career as a central exhaust treatment and chemical operations engineer, but now I work with water. Now, this isn't your ordinary water. It may start out as tap water, but after over 30 process steps, this becomes ultra-pure water. This is some of the cleanest water in the world, and we make 2 million gallons each day. For example, we measure contamination in parts per trillion. That's like taking 1 grain of sugar and putting it in a swimming pool the size of an Olympic swimming pool. Behind me, you can see our reverse osmosis system. Here, we take high pressure and force water through our semi-permeable membrane. Water can pass, but contaminants like salts are left behind. And that's only the beginning of our process. Since chemicals are used in semiconductor manufacturing, proper exhaust treatment is very important. Here, behind me, we have a wet fume scrubber. This is used to treat acids and bases. Now, this isn't a scrubbing action, but more like a shower. Water flows down as exhaust is pulled up through packing. This packing breaks the water into smaller droplets to provide more surface area so there's better mass transfer. Chemicals go down the drain and clean air exits the stack. Behind me, you can see our ion exchange vessels. Water passes through here and all charged species are removed. This is the final stop in the central utility plant before the water heads to one of 8 final polish skids. The ion exchange resin, little tiny beads as you can see in this jar, are used to trap all those charged species, but we also continuously monitor at the polish skids. Water never stops flowing and we never stop monitoring. But where does all that ultra-pure water go? Where does the scrubbers drain to? Welcome to the Fab 9 Industrial Wastewater Treatment Facility. Here we process 3.2 million gallons of water each day. This is the same amount of water that 38,000 typical Americans use each day. Here we have a clarifier. Dirty water enters the center, and as it flows up, it's trapped by a layer of polymer and coagulant. Clean water overflows the weirs, the pH is adjusted, and the water flows to the river.
Fab 9 houses a photomask manufacturing facility which services wafers produced here and at other GLOBALFOUNDRIES fabs. Masks are an essential early step in the production of semiconductors as they serve as the blueprint for the ultimate product, the semiconductor chip.
The Burlington Mask House is the starting point in the chip making process because without the patterned 6-inch quartz photomask or reticles we produce here, the wafer fabs would have no way to get an image on a wafer. By operating its own mask house, GF is able to produce leading-edge technology, extremely fast turnaround time for their customers, as well as reap significant cost savings by keeping the work in-house.
The mask house measures close to 100,000 square feet, with over 20,000 square feet dedicated to an ISO Class 10 environment, which allows for only 10 or less airborne particles per cubic meter of air. This level of cleanliness is essential for product quality and is achieved through the use of massive air handling and filtration systems, which make our manufacturing space far cleaner than your average operating room.
When a mask order is received, our document preparation, or doc prep team, starts the process by setting up each mask layer in our manufacturing execution system. A simple microchip might require a dozen or 2 unique photomasks, where a more complex design may take as many as 100 or more unique mask layers. Then, through a process called fracturing, our software applications convert the electronic design data we receive into meaningful computer code that our write and measurement tools can handle. Fracturing is very computer intensive, and data conversion can take as little as minutes or as long as 24 hours for a more complex design. Once all data is fractured, the job is sent to one of our write tools for the printing process to begin.
During the print process, the mask will be exposed to either a laser beam or an electron beam, which will precisely write a detailed pattern into the photosensitive film on the mask. The printed mask is then developed and etched, leaving only the desired pattern on the mask. Next, the mask goes on to inspection and metrology.
When we do measurements, they are taken to ensure the image is properly located on the mask and that critical features are measured accurately. In order to do this, we utilize both electron and laser beam technology. And we actually measure down to 1/20th the width of a human hair.
After all measurements, inspections, and repairs are completed on the mask, it's now ready for the pellicle mount sector. A pellicle is a thin, transparent membrane that seals off the mask surface from airborne particulates and other forms of contamination. The membrane is mounted on an aluminum frame that adheres to the mask surface during mask processing.
Our production control team is now ready to verify the mask certificate of conformance paperwork is finished and has been completed properly. The mask is then bagged and delivered to our production control team, who will package it up for shipment to one of GlobalFoundries' many wafer fabs.
From the mask house, wafers move to the fab itself for a transformational process. In the fab, they will be exposed to a series of physical and chemical treatments and washes that ultimately give the integrated circuits on the wafers their innovative attributes.
Hi, I'm Kevin Kofalici, a manufacturing manager here at Fab 9. I'm going to take you on a brief tour of the line and take a look at the role of the manufacturing team. The Fab 9 manufacturing facility is split between two connected buildings covering 470,000 square feet. There are almost 900 tools spanning the two buildings. These tools perform different functions on the product as it moves through the manufacturing line. Tools run 24 hours a day and 7 days a week, just like our manufacturing team. Let's take a look at a process aisle and see some of the roles operators perform. The operator's primary responsibility is to load and unload product on the tools. They're also responsible for qualifying the tools for production. These qualifications vary based on the tool. For example, one of our qualifications tests the tool for any dirt or FM that could damage the product. This is why we always wear our suits inside the fab. Typically, 2 to 3 operators will be responsible for all of the tools in a work area. Depending on the work area, an operator could handle a couple hundred boxes of wafers over the course of their shift. Operators receive a signal that a tool is ready to be unloaded. The operator scans the box out of the tool using a wireless wander. This scanning process keeps track of the box everywhere it goes in the fab. The operator removes the box of wafers from their tool and places it onto a cart for transport. From the transport cart, the operator places the finished box of wafers into a whip station, once again scanning the box. The whip station is a tool that holds boxes until they're ready to move to the next operation. When a box is ready to run on the next tool, the whip station places it onto the overhead track for delivery. This transportation system is fully automated. At the destination area, the operator is alerted by a flashing yellow light. Now that the wafers have arrived in the whip station, the operator can remove them and load them onto their tool. This tool is loading in batches, meaning more than one box is processing at a time. Because of the variety of tools in the fab, an operator must be trained and certified on each tool they run. At the end of a shift, operators from the outgoing team pass on the tool and work area status to the incoming team. There is a 10-minute overlap between the shifts for this interaction. Once this is completed, the outgoing team's shift is over and they head out.
Now that you've seen how our manufacturing operators interact with the wafers, let's take a look at the electromechanical and controls end of the equipment, as well as the technicians and engineering people that collaborate to keep the equipment running in top shape and ensure quality product.
Hi, my name's Scott Rochester. I'm a maintenance tech in photolithography in Fab 9 in Burlington, Vermont. In this particular tool, wafers are applied with a photosensitive chemical called resist. Light is transmitted through a mask. The circuit image is impressed upon the resist on the wafer. Once the wafer has been completely exposed, it's baked to set the lines, and then it goes into a develop process, much like the old film developing, where resist that has not been exposed is removed off the wafer, and the end result on the wafer is the circuit repeated over and over on each chip on the wafer. This is pretty much the final process at this step before it moves on to other parts of the line.
My name is Ian Mattoon, and I'm the equipment engineer for the metal etch tools here at GLOBALFOUNDRIES Fab 9. These tools are designed to etch away metal on top of the wafers after a photomask is put down. It does this through a combination of various gases, temperature, pressure, and powers. After the metal is etched away, the wafer is passed to a strip chamber where residual resist is similarly removed. In this manner, metal features such as wires are made on the wafer.
My name is Lauren Bailey. I am a process engineer here at Fab 9. I am responsible for the silicon dioxide deposition toolset. My daily responsibilities include working on continuous improvement projects and optimizing process controls. These tools are designed to deposit silicon dioxide in a uniform layer that acts as an insulator for the devices. In this particular tool, the deposition occurs through the use of 6 shower heads. The wafer rotates from shower head to shower head through the use of a spindle located in the center of the tool. My favorite part about my job is the freedom. If you have an idea and can prove that it works and makes the process more efficient, you can put your idea into production. You can come into work every single day and see the impacts that your change has had on the business.
Hi, my name is Rochelle Akimana. I'm born and raised in Rwanda. I'm a process technician here at Fab 9. I'm responsible for physical vapor deposition tools known as spatter tools. Spatter tools are multi-chambers with different flavors of materials, and they're designed to deposit metals on the wafers, and that process is done in high vacuum. The fun fact about my job is that the work is always changing. One tool can have more than multiple chambers at a time. That opens doors to more learning and discoveries. Also, the team that I work with has helped me learn and grow the skills of my tool set, also made me feel comfortable in my community.
When the wafers leave the fab, they proceed to another key component of our Vermont facility, the post-fab test center. This group plays a strong role within GLOBALFOUNDRIES' product portfolio, partnering across the company's business units worldwide to provide value through test differentiation.
My name is Jason DeRosa. I am the Director of Test Development Engineering at GLOBALFOUNDRIES. I'm standing inside the Test Development and Manufacturing Center located here at Fab 9. Test is where we apply pass-fail criteria to all of the wafers that GLOBALFOUNDRIES makes. We're looking at every individual chip on the wafer. We also provide a value-add service by doing redundancy memory repair. This is where we take bad devices and actually can make them good. We do all the engineering development here with wafers that not only come out of our Burlington Fab 9, but also out of all the fabs in the GLOBALFOUNDRIES. They'll come here for the development, and then we will quickly transfer the high volume production to either our manufacturing center here or over in Dresden, or using one of our third-party manufacturing suppliers that are located in Asia and Canada.
My name is Kaushal Kannan. I work as a test development engineer in the RF test team at GLOBALFOUNDRIES. We develop our own custom test solutions for emerging products in the 5G applications and cell phone applications. The team's expertise has allowed for valuable solutions for products running from 6 GHz up to 86 GHz. This is our own industry-leading custom design test solutions for the RF products. For every product that we test, we design our own custom probe cards and design our RF PIBs, which is the probe interface boards that go along to contact onto the products.
My name is Kate McLean, and I'm a member of the Silicon Photonics test development team. Silicon Photonics is an emerging technology that utilizes infrared light to transmit data at high speeds. A cost-effective industry solution wasn't available, so we created in-house test systems to enable both electrical and optical testing of these devices. These systems provide test data to the fab and development teams in order to bring up the technology from early phase development all the way to production.
We hope you enjoyed this brief tour of GlobalFoundries Fab 9 in Vermont and have a better understanding of what goes on behind the walls of a semiconductor facility.